I am Amy Phillips. You can find me on Twitter. That's usually where I'm chatting about things, mostly continuous delivery, but quite a lot of testing as well. And I also blog a little bit. So I write a bit about continuous delivery, but also, as I say, general other things that interest me. So feel free to come along and let's have a chat. So I've been testing for about 10 years now. Started out as a test consultant and very much sort of proper by the book, test strategies, master test plans, test plans, test requirements, the full thing. And I was a consultant, so we would have a team, we would roll onto projects when all the coding was complete, and we would do a whole load of testing, raise up a whole load of bug reports, and generally roll off the project before anything went live. And that was just the way things were. And I don't actually think that in all those years, and I probably did that for about 2.5 years, I don't think I met a developer. It was amazing. We were just testers. We went in and we tested. And over the years, eventually I got into more agile type projects, and it was much more collaborative, and we were releasing maybe fortnightly or monthly. It was close-knit teams. We were sharing, knowledge, exchanging ideas, and it was great fun, really fast, felt really fast-paced. And then about 3.5 years ago, I joined Songkick. And Songkick is one of the sort of early London-based startups. So we're over in East London, which is feeling a bit scary for me as I sat on the Central Line for 20 minutes. I was like, this is new areas. I've not been over this far west for a very long time. But we are quite a small team. We've been growing really rapidly over the last few years. We've actually been going now for 7 years, so we're quite established these days. And basically the whole sort of idea of the site, the whole reason it got set up was because it's really hard to see your favourite bands when they come to play in London. And it was really frustrating that the first time you hear about the show is in the metro or on the tube and it's already sold out. So the whole idea was to get people who love music to see more live music, and that was the whole sort of basis of the website. So it started out as a website. We've now got an Android app, we've got an iOS app, and we've been working on loads of exciting things like crowdsourced gigs and making it's always sort of fundamentally been a fan-facing website, so it's for fans to go and find out when your artists are coming. But now we've also got an artist side, so they can come in and they can manage their tour dates and they can manage their media, and they've sort of got a bit more control over what's going on there. And then more recently, selling tickets. So we can now provide the whole end-to-end process, which is just hugely exciting as a fan, that I don't have to buy a ticket from Ticketmaster, which is just fantastic. So lots of exciting things going on. But we're a startup fundamentally, so we have startup roots. And that means we are really lean, we get really frustrated, like a weekly release cycle is terrifying to us. It's born from the days of a couple of developers writing some code and putting it into production and hacking it together to make it work. And yes, now we have a great development team and test team and product managers and sort of all the aspects, but we still maintain that kind of core lean feel to our business. So it's quite a flat hierarchy, and we always want to sort of get things shipped as soon as we can. But ultimately, it's all about the fan for us. So I've come along tonight. Quite excited that we've got a testing topic. So I've head a test at Songkick, and testing's my passion. It's really great, like with continuous delivery, to see how testing sort of merges into all the aspects. You just can't get away with testing being treated as a phase. It has to be an activity, and it appears sort of right throughout the pipeline. So kicking off some testing stuff. So, basics of what testing is. And I think a lot of people get sort of caught up in thinking testing is the sort of thing you do when you sit down in front of the system and you decide if it works or not. And you're basically validating, does it work or not? But actually, it's so much more than that. It's a search for information. So you don't know what you're going to find when you start testing. Everything you do is to answer some question. And so everything what happens when I press this button? What happens when the user submits that form? What is this system meant to do? Every single thing like that is what you're trying to answer with your testing. And what that actually means is that testing is taking place throughout the whole project. So actually, as soon as you see a prototype and you're interacting with a prototype, you're testing, because you're gaining information about what the system is doing, how it should work, expectations that you might have, or assumptions even that, oh, okay, that's surprising, I was expecting it to work in this way, you're starting to validate that and learn about the system. And conversations you have with various different people, developers, product managers, all these people, you're actually gathering information and building up the picture of what you think the system does and how it's going to work. And then you obviously can feed that in. And when you do the testing as we sort of know it, where you sit down and you've got this fully built system, you apply that all back together and you have this big picture of, you know, how you think it should work. Who are the users? What do they expect from the system? So it's a much bigger thing. It's an activity that's taking place all over the place. And you're testing all day, every day. Every lift you get in, you're testing. You press a button, you have a really big expectation of what happens next. You're expecting doors to close and the lift will go, and you're hoping you'll arrive on the floor you selected. You know, all of that's testing. When it doesn't happen the way you expect, like, oh, okay. Something's more surprising than others, I should say, like lifts, beyond surprising, I'd say. But, you know, the self-service checkout at a supermarket, like, oh, okay, well, it's a bit surprising. I wasn't expecting it to react in that way when I pressed that button. So you're testing all the way. And quality, I think it's really important to mention that, well, Jerry Weinberg, firstly, if you haven't read anything by Jerry Weinberg, you should. He's got loads of books. He writes fantastic things. He writes really great things about writing and about consulting and also about testing. But really great guy, and loads of good stuff there. And he always says that testing is value, its quality is value to some person. So that's really important because what we've got there is some person. It's not the user necessarily. Probably your user is included, but there are other people involved. And quality, there's quality to developers, quality to your business people, to the support team. There are lots of different people who have some interest in the system and have some expectations. So when you are testing, you should be thinking about, okay, is this a quality system? Who is wanting to use it? What are they expecting to get out of it? Okay, so testing. Testing's easy. This is why we automate everything. What about if we wanted to test that we've rolled a 1 on a die? Pretty easy, you can say. You roll it, and you check how many dots are there, and there's 1. So we're good. Test is passing. And then you probably want to make sure that that test is going to fail, because you should be careful. If you are automating your tests, do make sure they fail, because that's a bit surprising otherwise later. So you probably want to make sure that if it's a 2 or a 4 or a 3, then that test will fail. So that's pretty good now. You know, we know we've got 6 sides to a dice. We've got the 1 checked off. That's great. We've got the other numbers all checked. Excellent. We're pretty happy. I think it's easy to stop there and think we've tested pretty much all the things we can test on this. It's a pretty simple system. Okay, but what about this one? Should that test fail or pass? It depends on your context. So if you're at home playing with your kids, I think it probably passes. It's definitely a 1. That's fine, isn't it? If you're in a casino and suddenly they pull out a random red die and roll it, I think I'd be very concerned. Like, why isn't that white? What's special about this one? Where did the red one come from? So it depends on your context. You know, who are the users? What are their expectations around this? And what about this one? So we have our test that checks that you've rolled it and the visible face is a 1. Unfortunately, they're all a 1, so our test will pass, and not necessarily wrong, because you did roll a 1, but it probably isn't what you were expecting to happen. You were probably expecting it to have other numbers that could possibly appear. And so you suddenly find that maybe you need some sort of sanity testing around the sort of state of the die before you begin this test. Like, what colour is it? Does it matter if it's a different colour? Or what is the setup? What are the 6 sides showing me before I begin testing what the possible results are? So it's getting a little bit more complicated. Okay, this one. Does it matter? The spot is quite a lot larger and it's a different colour. Does it matter? It depends. Depends on your context. What about this one? Did you roll a 1? You did roll a 1. Does it matter that your die is amazingly a portal cube which has been 3D printed in metal? I mean, that's incredible. But not in a casino, I would guess, again. Not in a game where it matters if you have multiple dice and you need to know, you don't want to know which one you're rolling, because that's probably going to be quite distinguishable from the other 3 plain white normal ones. So suddenly we see that context is really important here. You can't just assume because something looks quite simple, there are, it's a 1, yeah, it's good, let's go. We're completely safe, we've tested everything. There's lots of variants that suddenly start to come in. And I think there's lots of things we haven't even touched on here, which might be only significant like one time. So in the manufacturing of this die, maybe you need to consider what the properties are of this die. If that has the consistency of jelly, I think I'll be quite surprised when I pick it up. But you have assumptions that it's solid and it's a certain size and weight and it rolls in a certain way. But that's probably only a one time, as I'm manufacturing this die, I need to worry about that. So there's suddenly quite a lot of things that we need to consider. So what are we doing there? Firstly, we've got the really basic stuff. We're checking the result of our die. We've rolled it, we're expecting a 1. We can do some basic tests around, is it a 1, yes or no? What else? Does it fail, pass? Are there other sides? That's really straightforward. And then we've got the more in-depth stuff, which is what we kind of call more of testing. So this is where you need to engage your brain and you start thinking about things. And there's a lot more it depends involved and understanding your system, your context, and your users. And only really humans can make those judgments. So it's not black and white. It will never be black and white. And there might be times when you're testing something and it can be passing one day and actually circumstances change. And the next day, actually no. In this case, that can't pass because of these reasons. So it becomes a lot more complicated, and there's a lot more. Testing is a human activity. You need to think. You won't be able to automate everything. So bear that in mind. So if you want to know more about the distinction between checking and testing, Elizabeth Hendrickson says it best. So read her book. It's fantastic. Really easy read. It's not a long book, but really, really great book. Okay, so automation. We've touched on some of these. The myths on automation is you can automate 100% of your system testing. You can never do that. And you would never want to do that because you would have so many tests that your test would take forever to run. And there are so many things which you do only want to test once or twice. And then why would you want to have automated tests that you run every time for the next year? It's not a risk. It doesn't matter anymore. You won't be able to automate the things which are very context-based or the unexpected things. So the problem with automation is it relies on you knowing what the outcome will be. But sometimes you don't know, and you can't predict that. And it's actually only when you see it in action that you can actually go, okay, how do I feel about that? Surprised, okay? Why am I surprised? That's a problem. We don't want the users to feel surprised when they're using your system. So you can start to build that into actually the way you explore the system and build around that. So you cannot automate that. And once you've got your automation, you cannot guarantee your system will keep working, okay? Even if you've literally tested everything, apparently, you cannot guarantee it. The reason for that is because you can't. It's impossible. You can never think of everything you need to cover to test everything. You would be there for years thinking of little things and automating it, variants of the little things. And unfortunately, you only need one of those to fail to prove your system isn't working. So the odds are really in favor of your system not working. You can have infinite tests must pass to say it's working, or one test to fail to say it's not working. So you're never going to achieve perfection. I think that's the key thing here. You need to manage everything by risk. You do need automation, but don't try and automate everything. Okay, so bugs. Bugs come from everywhere. And bugs are all around us. Some people will find that something is a bug, and others will disagree, because not everybody experiences bugs in the same way. But generally, it's things like it's not meeting our requirements. So somebody had expectations that they defined for this system, and the system doesn't meet them. Or maybe the users have expectations. So these won't necessarily be defined in documents, but users do come to your system with an expectation of what's going to happen. If you don't meet that, maybe that's a bug. Is it difficult to use? We all know usability bugs. To be honest, if you have a system, it can be working perfectly. If you don't have any usability, it really doesn't matter because they can't use it anyway. And inconsistency. So obviously we've got inconsistency around the actual site, which, obviously that's a pretty straightforward bug. But what about inconsistency with users' mental models? So they've typically used similar systems. They come to your system with an expectation that it is like an email system or like whatever. They have some expectations around consistency. You do need to meet those models, otherwise they'll be confused. So maybe that's a bug. Or if it doesn't scale, is that a bug? At some point that's going to hurt you in quite a bad way. Or it can't be maintained. That's also fun. Everybody, I think, has a little bit of code which is like a black box and nobody dares touch it because you don't quite know how that works. Somehow it works, but no one's sure. And things can be really difficult to test. And again, I'd say that's a bug. Because even, if you can't automate it, sure, maybe you can do manual testing on it. But if that's difficult as well, that's going to really lead to problems. So we have all these different types of bugs, and they come out at different times. They won't necessarily be obvious immediately when you're building a feature. It might be that in 6 months' time you realize this really doesn't scale. You need to deal with that. That's a bug. So a Songkick, the old Songkick way, I should be very clear so we don't all get confused and everyone scream at me for the way we do things.
Come on, that's not Songkick specific.
So, when I joined, this was pretty much the flow we had. Now, we were a startup, we had a process, it was working for us. As we expanded the team, we found that we ran into a few problems. So basically, what came about was that we would commit code, and we had a whole load of automated tests that ran. Mostly they were integration tests. We were using Cucumber. We enjoyed our TDD. We had some tests. We were happy. We would then manually deploy this to our test environment, and there would be a whole load of feature testing and release testing. I was doing that, and I was also had people design, was checking things. The UX team were checking things. We were signing off on the copy. There were lots and lots of different things taking place on that test environment. So 2 problems really straight off. One was you've got lots of different people needing to be available at the same time. So that's quite hard to coordinate. If somebody was in a half-day meeting, what do? Do you release without their sign-off? It wasn't really an official formal sign-off, but everybody was a bit unsure. Or do you just go ahead and then know that the likelihood is you'll have to do a fix later, which tweaks a whole load of stuff? So you've got some questions. And we're also going to find bugs. If you test that much stuff at that stage in the process, you will find bugs. If you're doing all your feature testing and all your design sign-off and copy sign-off and things, one of those is guaranteed to be wrong. The problem we had really was we're all perfectionists. So we were like, oh, we know that's wrong. We really want to fix that. It would be so much nicer if we could just get the copy tweaked perfectly, or if we could just get that annoying bug rolled up. So we would commit a fix for that feature. We would run another build, and we would do some more testing. And only when we were happy with that would we deploy it. And another little problem that came about was because we were finding all these bugs, it was a bit tricky to identify, okay, what particulars caused that bug, particularly like regression bugs, which appear to be unrelated to anything you could possibly have changed. So we didn't really like committing multiple changes into one release. So we ended up with this queue. And in this queue, we had a load of developers who were sitting there with code, which they said, yep, this is all good, I'm done, this is ready for production. And they couldn't do anything until the pipeline opened up again, until we had the feature. So there was lots of waiting around, there was lots of coordination. And basically the problem was, we were aiming for perfection. Don't ever do that. You'll never achieve it. Because even after doing all of this, it was basically, the problem was, we were still getting bugs in production. Because you will. The bugs are everywhere. You will never catch everything. So we knew we had to change. So the first thing was to think about why we had this process. Because I think it's quite rare to design a release process. It's much more that you sort of have a release process, particularly early days where small teams hacking code, put it to production, tweak it, make it work. And as you add product teams and testers and other developers, you don't tend to sit down with a blank piece of paper and say, what would I like it to look like? You sort of just hack it together. So we ended up with this process, and we realized that actually when we did a release, if something went wrong, we added some security. And then we did another release, and maybe something else went wrong, so we added a bit more security. Over time, it means you lock down your process so many ways. So suddenly, Friday afternoons, don't ever deploy on a Friday afternoon. It's really stressful when it goes wrong and everybody just wants to go to the pub. So that was bad. So Friday afternoons are out. You know, don't try and release different change sets in one go, because when one of them goes wrong, it's much harder to work out where that problem came from. So stop doing that. It's all one at a time. You know, lots of little rules like that creep in. And you end up with this really inflexible release process where regardless of what you're releasing, it's going through this really rigid process where, you know, you've got all these rules, and it basically just means eventually you grind to a halt, because as you scale your team, you make your release process safer and safer, you stop being able to release code. And that's not a very happy place to be. So we knew we had to change this. So we basically realized we quite liked controlling things. We were locking down our release process. But at the same time, we were trying to release features as soon as they were ready. So we knew we had to make a decision. Do we go with more control? And we actually accept that we need a bit more safety. We're going to have to schedule these releases. Maybe we now have a weekly release. We get a release manager who coordinates everything. We can have code freezes, test phases, do the whole thing. Or do we have less control? And actually, we go with continuous integration. And that was the thing for us at the time was, wow, could we actually do it so that developers can just push code whenever they're ready, and we have tests and things in place that mean we don't just completely overload our test process? What do we do? And we decided that actually we took a look at our core values. And these were our real values at the time, which was shipping features as soon as possible. So we don't believe that it makes sense to build a new feature or particularly maybe fix a bug and have that sitting in an environment for perhaps 5 days. We just don't like that feeling. If it's ready for the user, it should be with the user. And we've always had developers responsible for our production quality. That's always just been a thing. If you put code into production and it doesn't work, you must fix it. I find it insane when I come across teams where there are production bug fixing teams, because it should be, if you're writing code, your code should be good enough to be working in production. If it isn't, you should make it that way. So we've always had that where developers are really responsible for production quality. And we realized these things set it up really well for continuous integration, which, to be honest, everyone was much more excited about continuous integration anyway. We didn't really want to have code freezes. That's a bit of a nasty place to go. So this was looking quite good for us. Okay, so we've got our old flow with lots of people, lots of things going on. And just to give you a sense of sort of timing on this is, as we committed the code and ran through the tests, it was taking us an hour to get that build out. So that was pretty slow, especially if you consider that once we spend 2 hours doing our sort of manual feature testing and stuff, we would find a problem and begin the whole thing again. So we were doing pretty much one release a day because we generally did each one twice. So we knew we had to sort of loosen that up and speed it up a bit. So the first thing was our test strategy. So obviously 2 hours spent doing our feature and release testing, that's quite a long time. And we're still finding a lot of bugs, so that's a bit surprising as well. And I think actually you find that developers are writing lots of unit tests and integration tests. Certainly in our case, they were writing tons of integration tests. And most times they were actually firing it up and doing some manual checking as well on their dev environments. And then when it gets to the testers on this other side of this wall, the mystical wall, you find that testers are sort of doing a load of manual testing. They probably have regression test suites, maybe lots of them. And they're also sort of doing automated checks. They've got tools they use to unearth nasty little bugs. They're doing all sorts of clever things. And actually, when you put those together, you find there's a real load of overlap. And actually, it's really surprising if you take a look at what developers are testing and testers are testing. You're like, oh, Okay, I didn't realize you even knew that we had to test that aspect of the system. It's so divided that you don't get that coming together. So everybody's sort of wasting time checking the same things. So straight away, you can have a single test strategy where you agree as a team, these are the areas we need to test, and these are the risks we're addressing here. And then you can work out, okay, we've got a team. How does this fit together? What level is testing and what's checking? What's the simple stuff we can just be ticking off quite quickly each time? And what's the other stuff which is more difficult and more questionable that we might need to investigate? And this is all the team. You have developers and product managers and other people who can help with this. It's not just that the tester has to sit there and tick things off. Everybody can be involved and everybody should be involved. And then once you've got that, you start dividing. Okay, well, how much of this is a human aspect? You want to automate as much as you can. You can automate quite a lot of this stuff, and machines can be running it for you. Machines can be running it and outputting files that humans can be checking. There's lots of ways to speed up and make your testing much more smart. But that should be, everybody in the team should have the input into deciding that. And I think it's really rare, again, that I think unit tests have always been seen as the thing that developers write, and they're sort of left alone to write that. But testers should have input into that. You don't necessarily want to just unit test every little thing. It should be risk-based. And then testers, on the other hand, are sitting there and they are trying to test the whole system. And actually, developers have got quite good insight into what they changed. And sure, maybe you want to check a few additional things in case they're a bit overconfident, but I've had many a time where a developer's like, no, you can test that if you want, but I haven't changed a single bit of code. Honestly, I'm telling you, please trust me. And you've got to sort of build that trust up together. So you can sort of really optimize your testing by sort of thinking about it as a team activity. Okay, so we added a new value. So we were going into this, and we have multiple developer teams at Songkick. At the moment, we have 3. 2 to 3 is our normal number. And I'm the sole tester. So for this to work, we had to make developer teams responsible for their own testing. So, bit controversial, developers testing. But the critical thing is teams. There's more than just developers on a team. They have designers, they have UX people, they have product managers. And there are many times where those people are actually better at doing the testing than the testers. A designer is going to do a better job of testing out the design than a tester because they know what it should look like. And if you've ever had a designer tell you that something is the wrong shade of grey, then really, trust me on this, I'm blind to at least 10 shades of grey, but they can see these things, it matters to them. And the other thing here was the freedom. So the test teams were responsible. They could decide how they worked with that. Sometimes the teams swap over work and they test each other's stuff. Sometimes developers within those teams pair or swap work, or maybe the product managers does all the testing. They have the freedom to decide how they cover the testing. And that means that you've got testers responsible for quality, and they actually have the bigger picture. So I actually have the time to be talking to all the developers, helping them test, teaching them what testing is, and educating them. Like, we play the dice game on a regular basis, and it's great fun. There's endless variants of dice games, and they're just so much fun because everyone's just ridiculously hard, and you're like, oh, how can I get this? But those are the ways that people learn the skills, because testing, I think it's easy to fall into the trap of testing, thinking automated, and it's got testing in a particular way. But really it's not. Testing is about the way you think about things and seeing something and questioning what you're seeing and thinking about it much more broadly. So I spend much more of my time thinking about the overall Songkick quality, making sure we have consistency throughout the site, which with multiple dev teams, even the product managers don't have that sort of whole site overview. So you'll get sort of inconsistencies creeping in. So you sort of need to step back and make space for that. And one thing that's really nice once you start thinking about testing as a team, like a whole team activity, is you've also got this shared ownership of the automated tests. So they just fit in. We have it now where if you're building a new feature, we'll have a conversation. Okay, so what do we need to do with that test? What aspects do we need to add? Do we need to update them? That just is part and parcel of building a new feature. And everybody gets that. The whole business understands that as well. Like, they understand, okay, we need to spend another day updating the automated tests. Whereas previously, I think there was this kind of divide, like, oh, maybe the testers can just maintain those tests and it's free and it will just happen sometime in the background. Now it's all part of building and shipping. So it comes down to testing at the right level. So we found that we were using TDD. I think that quite often leads you to have a lot of integration tests. So we found that we had lots and lots of tests that were going through quite a lot of our system and uncovering problems. But there was a lot of duplication in there as well. So we moved that around. We dropped a lot of it down, and we have a lot more unit tests now. We cut down our integration tests. We accepted, okay, if we do that, there is a lot more risk because suddenly we're not testing how these bits interact with each other. But to be honest, for us, the benefits were huge. So we did that. And you've got this team ownership. So everybody, you can't suddenly find that you've got the mystery suite of tests that run and pass, and everyone's like, okay, that's really good. Those tests must pass, but we don't know what they test. Or when they fail, does it matter? Nobody knows. You have to fix them anyway because nobody's quite sure how critical that test suite is. So we don't have that. Everybody knows, okay, that test, what does that test for? That's going to Facebook Connect and looking for a test user. They know that in detail. They have to know that. And then everybody can influence what you're testing. So I think this is really key. Like, testers should be talking to developers about unit tests. They should be saying, I found this bug. How is this even possible? Do we have unit tests on this area of the code? If not, why not? Is it difficult? Maybe we should do that. We had an interesting one where, as we were moving to the stage of continuous integration and particularly continuous deployment, the business people were quite nervous. Like, okay, all they're seeing here is developers getting really excited about shipping code to production like 10 times faster than we have been done. So that was good. It was good that they were understanding what we were going to do. And we gave them the chance to have input into the tests as well. So we added a new layer of tests. And these were we call them acceptance tests. And they are journeys defined by the business. And one thing that's a bit unusual about these tests is they're actual user journeys. So I think normally automated tests, you go for sake of tests like sanity. Okay, you click a button and you check the result, test's over. Do something else, enter this form, submit the form, good, test's over. But users don't use the site in that way. Users come along and they sign up, and then they expect to be on a particular page, and then they go off and track 20 artists in London, and then they expect to be able to find, the latest gig in Hyde Park. And so we really tried to put that into our tests and create what looks like a realistic user journey. And that was defined by the business. And obviously, there were some guidelines. The business people were like, couldn't we just do this for the whole site? This is amazing. We could have every journey tested. But once you explain to them that every bug fix is going to go through the same flow, and really, if it takes an hour for all those tests to run, it would be better not. So we've got that limited, and all of our tests must complete within 10 minutes. Otherwise, we stop everything and we go back and do that. So at the moment, the automated tests, the acceptance tests are our slowest ones. They're taking about 5 minutes to run. They just test absolute critical journeys through the site. And that means that every time we do commit the code, we know we've got the tests that we care about running, and we still get the fast feedback. So, developers don't get distracted. Previously, when a build took an hour, we found pretty much everybody committed their code right before lunch, because then they could go away for lunch and hopefully return to a green build. The problem is when the build fails, it usually fails about 5 minutes in, and everyone else has to sit and look at it for 55 minutes whilst they're on their lunch. So now we have this fast feedback, less than 10 minutes. It's long enough you can get up, you can go and have a cup of tea. It's not long enough that you get caught up in something else. So that works quite nicely. And it all comes down from risk assessment. So every time we start a new feature or an experiment, we have what we call a kickoff meeting. And basically, these are the people who are interested in this feature, I guess. So the ones, I suppose, who have expectations, that have some hope of quality coming out of this feature. So that will be the developer who is actually going to write the code, be the product manager. It might be a sort of more senior sort of architect type developer person, tester, designer, perhaps somebody from the support team, UX, all of these different functions will hopefully all get together, have a quick conversation. It's about 10 minutes long. And we basically talk through, what do we want to build? Why are we going to build it? What measurements, do we have? How do we know if it's successful? We talk about the technical side of things. So even if not everybody understands exactly what's happening, maybe the designers don't understand the technical details that the developers are having, it all happens at the same time. And then most importantly, we talk about how we'll test this and what are the risks of this. And then we try and talk about how we can mitigate the risks. So we have different features, like there are different risks. Maybe we realise that this one's going to need performance testing. Okay, so how does that fit in? That we typically do outside of our sort of deployment pipeline. So then we'll talk about when will it be ready? Which environment can we use? What data do we need for that? Or maybe it's a particularly high risk change. So if it's something like a new sign-up flow, then I would consider that quite risky. So generally in those sorts of ones, then I would say, I'm going to test this. Developers will still be doing testing, but they won't be the sole testers of that if it's a high risk change. Or maybe it's a really low risk change, like maybe it's just adding to something to our public API and it's not really user facing. That's great, it can just be done and dusted. So we have this flexible release pipeline. And because we've been focusing on testing the right things and the right things for each particular feature, we can actually now adapt. So it doesn't matter if, one day we're doing a tiny little feature, the next day we're doing a new website. We know how to respond and we know what to do to make that safe. Okay, so we've ended up pretty much the process along these lines now. So if it's low risk, we pretty much just leave the dev to it, to be honest, and they commit some stuff and it runs through our automated tests and builds and goes straight out to production. So that probably takes about 10 or 15 minutes. It's quite a quick flow. And if it's medium, which is generally new features and things, we pull the testing forwards. So we recognise that we still need to do this manual testing. There is a whole load of stuff that needs to be checked off in a new feature, design, we want to cross-browser it, we want to check off the copy. That will all happen up front on the dev VM. And that means we're not holding up any of the other teams. We can spend as long as we like doing that. We can iterate over that as many times as we want. It's pretty quick and easy to fix a bug when you're still on the dev environment. You just make a change. So that works quite nicely. We don't find we're held up waiting for people. And actually, design and dev pairing is becoming a really big thing because people are realizing the benefits of actually having the designer sat next to them as they try and finish off the design. And they can actually discuss, no, actually, can you just tweak that around and maybe move that up a little bit? Yeah, that looks better. And it's a much more collaborative approach. And then when everyone's happy, when we do all agree that this thing's ready to go, we can commit the code, run through the automated tests, same automated tests, and if it's all going well, it goes straight out to production. But then we'll always have the sort of high-risk things. And then this is where we come in, same process, but here we know we need to do more testing. Now, the problem with a dev VM is you are not going to have like the same production sort of like environment. So we always have things that don't quite work in the production way. You don't necessarily have the same data. You certainly won't have the same load. So there are lots of things that are quite hard to test on a dev VM. So rather than block up our release process, we send all the code through to production and then we do all the testing that we want to do there. So we're using feature flippers to turn things off. And that means that we can do exploratory testing in production and we've got real data available to us. Some questions about how you manage test data in production. There are lots of different ways you can do that. Generally, I think we know our data well enough that we can usually find the data we need. But sometimes, yeah, sure, you have to create test data and you have to create it in a way that's either clearly labeled or quite well hidden from users. But that gives us the opportunity to, we're doing the same testing. We're actually technically doing more testing these days because we have it at the beginning and at the end of the flow, but we're not blocking up our whole release pipeline. So we have flippers, really basic, just if statements in the code, but they're all managed from a UI. And this is an admin tool that we have, so we don't have to make a release to actually change the visibility of something. Anybody in the company has access to this. So at the weekend, if a support person's suddenly finding that particular component's causing trouble, they can go in here and switch them off. And that works really well for us. it had the sort of nice, unexpected benefit that we can do a whole lot more A/B testing now because we use exactly the same technology. So we can control percentage of users seeing a particular feature, or a particular type of user, like logged in users or logged out users or something like that. And yeah, basically it just gives you the freedom to push the code to production while still controlling when you do the testing. And then we're happy, everyone's sort of agreed that we're good to go, we can flip it on and watch it. Okay, I think this is a really big one from a testing point of view. It's actually quite hard to learn to trust your test results. If you're in a position where you normally are manually testing, and then you're saying, yeah, it's good to go, suddenly you're sort of letting Jenkins make this decision for you, and you're hoping desperately that you have all the right tests in the right place. So we had this on both sides. The developers had to really learn that they should never, ever release a red build. Usually they learn this on the pain of doing it once or twice, which is exciting. And particularly with our acceptance tests, because they are Selenium, so they're running through the browser, which makes them a bit more flaky. And unfortunately for us, our most popular journeys are using Facebook Connect, which makes them a lot more flaky. So we do have some problems with those tests, but we have had to accept, basically, that the security those tests give us, particularly the security that the business feel having those tests in place, is well worth it. So developers have to just, unfortunately, deal with the fun of those tests. And I think testers find it quite hard. I certainly found it challenging at first that, really, a green build, is that really safe? You learn that over time. You have to just reassure yourselves that, you looked at the tests are there that you want to have tested. Obviously, a lot of exploratory testing is taking place on production, which means you can learn from your mistakes. If you do find bugs there, you can question, like, okay, what happened? Where are the gaps in our process? And you can build those tests in. So we have a basic rule: you can break anything once. And I think when we started this, everyone was a bit nervous, like, oh, okay, this is a complete unknown for us. We are deploying code to production, and somehow it feels untested. So we had to encourage people, it doesn't matter. You can break anything but once, only once. So every time something breaks, we question why. We learn from that, we add tests, we improve our environments, we look into what caused us to miss that particular bug. And over time, you find your environments really improve, your test data improves. People get much, much better at catching problems. And I talked a lot here. This was very much our sort of process of moving into continuous integration. But actually, once we found that we'd evaluated our tests and we'd looked into what we were testing and when we were testing, and we found that it started off just being automated builds, but it was so difficult to remember to deploy the code to the test environment and then trigger the right tests and do that after you've deployed, and people were kept forgetting or thinking they'd deployed the code to the test environment before they ran the test, that actually we just automated the whole thing. And suddenly one day we realized we'd automated everything except for the bit where we pushed it to production. And we were like, oh, okay, it was a real anticlimax. Like, oh, okay, that was it. That was the final step to be continuous deployment. It was so much easier than we thought. So continuous integration was our real challenge. But yeah, we kind of just ended up with the majority of our projects continuously deploying. Okay, tools. I know you cannot possibly come to a talk like this and not recommend a whole bunch of tools for you all to go off and get excited about. First one is your brain. This is the most important one because you cannot, everybody needs to come together. You need to be thinking about what you're doing, why you're doing it, who are your users, and what are they expecting to get out of it. Ideally, you don't do this alone, because if you get the input from lots of other people, and if you get input particularly from people who are from different aspects of the business, they will bring great insights. And that's really where you can start to talk about, okay, we're going to release this, we're going to do this. What happens when it all goes wrong? And that's really interesting conversation to see how scared everybody gets. And actually, it's really nice, it's really reassuring to have that conversation and actually know, do you have a plan? Okay, do you roll forwards? Are you rolling backwards? Who needs to respond? And how will we know something's gone wrong? And for us, that meant that we put lots more monitoring in place. So now we've got really good alerts. After a deploy, we run sanity tests on production. We have alerts on errors on the servers and all these things that came about just because as a team we sat down and we thought about things. And the other one is must talk a lot, because good teams are always communicating. So this really is a team thing. You cannot just have one part of a business or a particular project driving this. Everybody needs to come together and communicate and talk about, okay, if we do this, what are the risks? And what are my particular concerns about this? And what do I think the personal benefits will be? Because everyone will have concerns. You're trying to change the way you work. You're trying to add sort of aspects to certain people's roles. So developers suddenly have got this testing like activity they need to be doing. And you've suddenly got testers who feel that, maybe I'm not doing enough testing here because I've spent half my day training a developer to do my job. But you haven't, because you're teaching everybody and you're all learning together about testing and quality. And that ultimately means you can move together, you can release things. So you can pretty much see when we turned this on. And actually, we didn't scale the team at that point. We weren't doing more work. This was just unblocking our pipeline. So this was the impact. This is releases per month. This was the impact of us just not having a queue. So code that was ready was actually being shipped as soon as it was ready, within the day, almost certainly. And yeah, we've been averaging over 100 releases a month ever since. So it's working pretty nicely for us. And I think one thing that you just get for free there is free batch, like small batches means you get free things. So on the first Saturday after we turned this on, the number of trivial bugs that got fixed was just phenomenal, because suddenly developers realized that it wasn't a real headache to make a change and commit it and get it into production. There wasn't like 3 hours of negotiating with different people. They could do it at home and commit it, and it went out. So actually lots of little niggly things on the website just suddenly went away because developers had that freedom. Okay, but it was obviously always much more about releases. So we didn't do it because we want to release loads of stuff. We did it because we weren't releasing anything and everyone was really depressed that we had these great features that weren't with our users. So now we've got, everybody cares about testing. They have to. It's a big part of their job. It's amazing. Everybody's really motivated to maintain our automated tests. Previously, this was always something which people tried to push off. Maybe the testers could do that. Could you add these tests later? It's a minor concern. Now everybody understands the value of the pipeline. Everybody appreciates the fact that, okay, well, this area has no tests. I'm really nervous about that. We get people who, when they start work on a new area of code, they're really scared, like, oh, okay, I don't like the unit tests. We don't have very much coverage. I'm going to write a whole load of tests before I begin on this feature. It's really good. Everybody is really motivated to keeping our pipeline moving. And ultimately, for the business, you can get bug fixes out there really quickly. So, I mean, there will always be bug fixes, but it's really, really nice if you get a user who tweets you. It's always the ones that tweet you, like, hey, did you know that this is wrong? And you're like, it's really nice if you can go back to them 10 minutes later and go, thank you, that one's fixed. Because it's so satisfying, There will always be bugs out there, but it's nice when you can just respond. Okay, so just to summarise here, you must automate things, okay? Don't get me wrong here, you can't automate everything. You don't want to try and automate everything. But, and it won't necessarily make you safe, but, you should be doing this. And when things go wrong, make that positive. Turn it into an opportunity to improve your environment or your process or your communication. Try and work out what went wrong. And finally, just don't neglect the human aspect. So there are lots of ways you can include the human in testing. You can be doing exploratory testing. You can be doing more outputting of automated logs or results or things that have a human aspect to checking them. But no, don't neglect that, ultimately, most of the things we deliver are for humans. So do check them by human. If you like the sound of what we're doing at Songkick, just a little mention. We are hiring.
But you aren't hiring testers.
We're not hiring testers. We have a tester and a great process. We are hiring a lot of developers and product managers and other areas. So if you're interested in that, come and chat to me. Okay, and there's a few more things here. Just put up my Twitter handle one more time. And there's my blog address and also the Songkick dev blog, which has a lot more detail on the kind of technical side of it. So if you're interested in actually what we did to speed up our automated tests or the particular tools we're using for testing, you can find out a load more on our dev blog, so take a look at Okay, are there any questions? Yes.
So if you were switching off features that were broken in production using a feature builder tool, does that mean like your site will be running degraded for a while till it's fixed? And how
Okay.
was management okay with it?
Okay, yeah, good question. So the question is around if we're turning features off on our website, are we running a sort of degraded website for a time? And, you know, is the business okay with that? It's a good question. Generally, we use the feature flippers for certain types of things. So it might be a new feature, something which we launched that didn't behave quite as we wanted. In which case we'll turn it off and make a fix and get it live. Yeah, it's not ideal. It's probably the equivalent of in the old system us putting it onto the test environment, finding a bug and having to go through a whole load of bug fixes. So it's all down to speed, I think. So we will, if that happens, we'd fix it pretty quickly. So it would probably only be off for an hour or so.
Oh.
It wouldn't be a huge length of time. We also would have let's see, we would perhaps have things which are maybe third party. If the third party gets into trouble, they would have to go off. Again, it's not ideal, but we have not very much control over that. Or there might be experiments, and experiments are quite interesting. Sometimes we put things up, it doesn't go quite as we hoped. Maybe we'll turn it off for a while, tweak it, or maybe the analytics aren't gathering in the background well enough, so we turn the experiment off whilst we fix that. So it's slightly degraded. Usually, I would say the majority of users probably wouldn't notice. I think it wouldn't be sort of like a core feature that's been up on the website for 6 months, suddenly gets switched off for a week and then later comes back. That would be extremely unusual. We try and remove the feature flipper as soon as we can. So it's more, we wrap a sort of high-risk feature up in the flipper, put it live, turn it on, and after a period of time, once we're like maybe a couple of days, we'll move the flipper code around it. So we go, okay, that just has become part of our thing. And then we can run regression tests and it's visible and we know it's there.
Oh, yeah, thanks.
Anybody else? Yes, Steve.
So, as you've reduced your batch size, the theory says that you should see defects in production decrease, both in terms of the number of them and in terms of the cost of defects. Is that something that you've seen at Songkick?
Okay, so batch size. So our batch size has decreased. Steve is hoping that we can engage in the conversation about the number of defects in production decreasing and the impact and cost.
Is that something you've had? Because theoretically that is what happens. It doesn't always happen, but theoretically you should have those benefits.
Well, it's interesting because actually I'd say in theory you've got a lot more defects in production because we do a lot more testing in production. But hopefully actually they're not defects the users are seeing because it's production code that we're testing behind a flipper. Batch sizes have decreased. So I think it depends because I think one of the real benefits of reduced batch size is knowing what caused a problem. So we took our whole website down because we made a 1-character mistake in a config file. For example, it was an extremely small batch, but it was quite a devastating consequence. But because we had made a change to one file, we knew which file had caused the problem, so we were able to respond, like roll that back quite quickly. So I think the problem with defects is you don't know where they are. You don't know what's going to trigger them. I think it depends probably on your code structure and how things are set up in the back. Hopefully, yes, I agree with you. Certainly we can respond a lot quicker, which does make them cheaper because you're not... Well, we're not hopefully holding up other people, we're not holding up other features. It doesn't take so much investment in time for a developer to locate the bug, fix the bug, and ship a bug fix. So in that sense, it's certainly cheaper. But I would be extremely reluctant to say whether there's less impact on a user. I think impact totally depends on what the bug is and what their expectations were they were hoping to achieve.
Sure, but so there's two-dimensional, right? There's the economic impact which none of us can control, but there's also the lifetime. And you're saying that because you've got a smaller batch size, you're able to respond faster, so the lifetime of the defect has come down.
Yes, the
so
lifetime
the
was
overall
certainly.
cost it's come down.
I would believe that's true, yes. Yeah, certainly we found we can respond a lot more quickly to bug fixes. And as I say, I think one of the real benefits is the freedom developers have. So, you know, developers actually do feel like the pain. They see a bug and they're just as annoyed as the tester who sees the bug. So if you give them the freedom, quite often they'll just go away and fix bugs. So we get quite a lot of bug fixes. The business don't need to prioritize them. We don't triage them. They're just going away and getting fixed. But as I say, I think the problem is it's still very unpredictable. So it's easier to identify bugs, sure, but you're not really reducing your chance of finding a bug in production. Yes.
Sort of related to this.
Okay, yeah.
At the
Yeah.
start about in the bad old days of Songkick, when you kind of encountered a problem, you'd put a more safety structure around it. You try and de-risk it that way. And now you've got in this brave new world, you still are allowed to break something once. How do you avoid sliding into de-risking things by locking them down versus not finding other ways of de-risking them?
Yeah. Okay, so that's a good question. So it's all around when things go wrong. Previously we used to lock them down, and now we're trying to keep things moving and flowing, and so it's, how are we avoiding just sliding into a pit of poor quality? And yeah, it's a real genuine concern, and I think you really have to hold yourselves accountable. You need to be questioning, okay, wow, why didn't that work out? And we're quite good at holding each other accountable. Certainly as a tester, I think you need to have oversight of what bugs are getting through to production, or certainly are being found quite late in the testing phases, because those are gaps, and those are gaps somewhere. They might be automated tests. They might be indicators of things that are really difficult to have automated tests for, in which case you need to think about how do you tackle that? What do you do? In lots of cases, I think it's education. So, if you are asking non-testers to be testing, they don't know that much about testing. So they're going to need to learn. They're going to need to understand how they look at the system to find bugs, and what are they actually trying to do? People sometimes ask me, like, okay, so we're feature testing, so okay, what do I need to do? What am I trying to achieve here? So I think a lot of it is just questioning things and just keeping your eyes open and just actually going, right, that release, what was it about that release that caused the problem? Is it something that's going to cause us problems on other releases? Was it a one-off maybe? And then responding in an appropriate way. So the thing which we try and avoid is just having blanket safeguards that affect every single release, unless they're automated tests, in which case they're usually pretty cheap. But yeah, usually we find that actually it's simple things like perhaps improving the developer environments. If we make them a bit more realistic, actually perhaps it's easier to see some of these bugs when you're writing the code, or sharing a bit of knowledge. So in Songkick, we obviously deal with concerts, but we also deal with festivals. And we call them events collectively because it's an event, but it's reminding people and helping them realise that actually a festival's got some real fundamental differences to a concert. For the first thing, it often doesn't have a location, like a real sort of venue. It's London. It's London Fields. It's a random part or field in Essex somewhere. It's very strange. And they have multiple stages and multiple days. And it's quite easy to make assumptions like, okay, an event, so venue name, and it will always appear here. And helping people and reminding them, oh, actually, don't forget, last time we did this, we forgot about festivals and they don't have a venue name necessarily. It's things like that. And I think it's education and just holding yourselves accountable.
So part of it's changing your mindset and looking at risk in a different way.
That's right. I think that's right.
I'm going to say that because Chris Max right? Chris Max makes the point that people prefer to be wrong rather than prefer to be for things to be unpredictable. Right? They prefer to be wrong rather than uncertainty. Right. And that's what you're talking about when they go back to having it locked down. Right? Going back to would be the wrong approach, right? But they don't know what the approach is because they got to find it out. Right? They've got to do some exploratory things. So what can we try to reduce the risk? And yes, you have to have that cultural education if you want to move away from people who kind of running to their safest place, the place where they're wrong, but where they feel most comfortable.
Yeah, And we were quite disciplined, like when we first started doing this, and we actually sort of said, if we have an incident, we will go through the 5 whys, and this person will run the 5 whys, and they will write up notes and email them to the whole team. And it was, and then other people could hold them accountable. They could say, hey, I noticed you did that, deployed to production, and the site went down for 5 minutes, but I haven't seen any analysis on that. And we would actually force ourselves. And I think you have to be really disciplined and actually say, okay, we're accepting a lot more risk here, but we need to deal with that appropriately.
Does this still feel like a loss of control?
Yeah, that's right. I mean, that's the thing. You're not just stepping back and going, hey, okay, let's go, see how it works out. That's not the case. We do have a lot more process probably now, and we certainly do a lot more testing now, but it's just probably a lot more visible. So there's not these sort of big steps where we go, hand over to you and you now do your role. It's, much more automated and fits together. So, yeah. Was there some people at the back? Oh, that's questions. Yeah.
How often do you release your mobile apps?
Okay, yeah, that's a really good question. So mobile apps, releasing mobile apps is an interesting challenge. So our Android app we haven't released recently at all. Unfortunately, we didn't build that in-house. We haven't quite yet transitioned that over to being built in-house. So that was a complete, waterfall style big bang launch, which was great. Our iOS app, again, we've moved that in-house. That one we use as much of this process as we possibly can, but obviously the Apple approval process means we can't use the exact same process. So at the moment we're releasing the iOS app once a month. So that's not too bad. We're doing about, we have very similar process to this. So say we have tests in place, we are writing code, the developers are doing as much of the feature testing as they possibly can, and then I'm around helping them out, exploratory testing, and then at the end we have sort of our regression testing, which at the moment is very manual, but it's one of those things we're sort of transitioning. So I think we're bringing a lot of the values that we use here and trying to sort of build that in, but yeah, not as fast as we would love to, basically. Other questions? Yeah.
Hi, I was wondering more towards the start of your process about your how you manage your code. I was wondering, are you using a branching model like Git flow, or are you just doing everything on master and then lots of testing? And if you are using branching model, how are you dealing with the testing of the branches?
Okay, yeah. So good question around how we manage our branching and whether we're working directly on master or whether we're branching and how we're testing those branches. And everybody pretty much works on master. There are some exceptions where somebody chooses to work on a branch. Usually that's for something experimental. Perhaps they're trying out some new technology or something which is a little bit different. But it's extremely rare that we would build something on a branch that gets big enough that it needs to be tested on a branch. We pretty much focus entirely on master. And the developers may choose to do something on a branch. It's their responsibility to get it integrated back into master, though. That's where we would do all of our testing. So yes, we've given the developers the freedom to work. I think the majority of them just work straight off master. Certainly that's where we would expect to take all our releases from and do all our testing on there. Yes?
So you said you've got developers doing bits of testing, and
Yes.
then you represent the whole of QA department at Songkick, yeah? Okay. But you also mentioned there's manual testing in there, so I'm wondering whether there were people who are entirely dedicated to manual testing, and what was the journey when you changed your delivery process?
Okay, that's a good question. So yeah, at the moment we have developers doing manual testing, and the question was about previously having testers doing manual testing and how that sort of affected their role. And I think there wasn't that much resistance because I was the manual tester and I was also the one driving this process through. And the reason I was the one driving this process was because I was the gatekeeper. And when your process isn't working and you're not getting any releases out, you don't want to be that gatekeeper because you have an endless flow of very unhappy people asking you when things will be released. So you've got developers, but also product people who are being told this feature's ready to go, but we can't ship it for 3 days because we're in a queue. Nobody's happy. So I was very motivated to move us to a much nicer process. But actually, yeah, of course, the process, the role changes. And I think the biggest change is testers need to have more responsibility. Suddenly you're not in a place where your responsibility is manually testing features or releases. Suddenly your responsibility is ensuring quality across the system, or certainly within your part of the system. So there's a lot more education needed. You need to be pairing with developers and guiding developers and other testers and helping them understand what testing's about. So there's a big sort of, broadening of your view there. And I still do a load of testing, don't get me wrong. I spend a lot of time collaborating with people and talking about risk and, like educational workshops and things like that. But I also do testing, and I find it's really useful if I know a developer is doing some feature testing, I will do some feature testing alongside them, like more exploratory things. I know they're sort of checking off the requirements. I can be doing exploratory testing of maybe more tester type things, because you'll always have that sort of separation. You won't have developers becoming specialist testers. That's not going to happen.
But did you have people entirely dedicated to manual testing?
Did you have what, sorry?
Did you have people entirely dedicated to manual testing?
We did. We had people entirely dedicated to testing. I don't think we ever made the distinction that you are entirely dedicated to manual testing. Like, we've always accepted that testing involves automation and it involves exploratory testing. But yeah, certainly until we made this transition, all testing was owned by me, by testers. And our developers were excellent, and they were already doing automation and having things, but they always had the safeguard. They knew there was a point later where there was a testing phase that testers did. And yeah, it was a big shift. It's why we had to bring in the value. Like, we had to make it very clear, developer teams own testing, because if you don't tell them, then they're not going to make that transition. So yeah, it was difficult from both sides, I think, yeah. Yes?
You said earlier that your acceptance tests are Selenium tests.
Yes.
Could you unpack what that means to you for us? I'm curious because you said earlier that you're blurring the line between unit integration and regression tests. So how does acceptance tests fit into that?
Okay, yeah. So questions about the acceptance tests. They're running in Selenium. So we basically have 3 layers of tests, and we call them like regression tests, but actually in reality, every time we build a new feature, we're adding things in. So a new feature is being regression tested, including its own tests, but it's just for ease. So we basically have 3 layers. We have our unit tests testing as much as we possibly can. Integration tests generally test within particular projects. Now, we're also using a service-oriented architecture. So we've got our system split up into quite a number of smaller services, and those communicate with each other via APIs. So the acceptance tests are Selenium, running in Capybara, and yeah, they are regression tests in the sense of these are our critical user journeys. We must protect them. So they don't get expanded out as we add new features unless that new feature is part of our critical journey. Usually they're not. Sometimes, yeah, sure, we change the sign-up flow. In that case, yes, you're also updating all these tests. But they are defined by the business flows, core functionality. Any others? Yes?
Are these tests executed in an end-to-end environment or locally per component?
Sorry, can you just repeat the question?
Are these tests executed in an end-to-end environment, or are they local per component? So you've got Selenium front end.
Yeah.
Do you have an end-to-end environment behind that, or is it just the component?
Sorry, I'm missing the end. Did you catch
Is it
it?
running against the component?
Oh.
Or is the Selenium test running against the component, or is it end-to-end? Does it touch all aspects of Songkick?
As in, do you
No,
use
absolutely
any,
not. It's testing the core journe's.
Okay.
So there were lots of parts of our site which are not core functionality. And I think any site you'll have that. Sure, users can control whether users can change artist images. It's not core functionality. So no, they don't touch any of that. Users signing up, that definitely is core functionality, so they're touching on that. So no, we don't attempt to have Selenium testing everything.
So sorry, Amy, it was more an end-to-end environment. So is it touching? Are there stubs?
Oh, sorry, I see what you mean.
Touching,
Oh, right, yes.
full
Sorry,
system?
yes. It's the full environment, yes. So we have a test environment which has everything, I believe, at the moment now. Previously it was sort of scaled down, but I think it now has everything on it. Because, yeah, that was the big thing, was that we accepted a load of risk with our integration test because they don't run full stack. So there will be a time where 90% of your stack is working and there's one critical part at the top which doesn't work. So yeah, the idea of the acceptance test is exactly that they do what the user does, so they see them. And I believe, certainly up until very recently, if not now, we also run the same tests on production. So it is designed to be, this is what the user is experiencing, is it working?
So you're reusing your acceptance tests as production smoke tests?
In a sense, we are reusing our acceptance tests as smoke tests. We have two builds. We have a sanity build, which is smoke, and basically the aim of that is to very quickly verify our deploy didn't do anything crazy. So our theory on this is we put a build on our test environment, and we've already run our unit and integration tests. We've run our acceptance tests on our test environment. So in theory, we're really happy. This build is working. It should be good to go. We want to make sure the deploy doesn't go wrong. That's ultimately what we're checking at that point. So when we put it to production, we have a sanity build, which is a curl script, which hits a load of pages and checks for errors. If that passes, we also have our acceptance test running. Yeah. Yes.
Yeah. You said you continuously deploy whenever you think like it's a low risk change, and as you have divided your system into multiple services, is it like if I made a change in one service, only that service go for deployment, and or that whole system get deployed?
Yeah, no, that's absolutely right. So we've divided up into services exactly so that when we make a change in one service, we can deploy a very small part of the website, and we can test that much more isolated and put that change out. So a couple of things around that is obviously there are some dependencies. So we have a tool which helps us manage dependencies on that. And we've quite carefully and painstakingly gone through, okay, we know that if we change this service, although we haven't changed the code on these places, we're having an impact. So we're running tests on those sort of related services. But yeah, the whole reason we moved to SOA was simply so that we can have these much smaller projects, much smaller code bases. You can make a change. We only have to release the relevant parts of the code. It was a real pain to have to release the entire website every time because that just takes a long time. It's a much slower process to update the servers.
And when you have made a change in your service and like you haven't touched any UI part of it, and are you still going to run those tests that run through Selenium and do that critical part?
Yeah, so it depends on the service. We've sort of risk assessed all of it, but in most cases, yes, the acceptance tests will run more frequently than they probably need to, because ultimately they are kind of consider them as our agreement with the business. They are the things which we've said to them, we won't break this. So if it means that the release needs to be 5 minutes slower because we're running some Selenium tests, we will do that, yeah. I mean, there are some things that are very isolated, and we have different suites of Selenium tests. So for example, Toolbox is our artist-facing website. It's very different from Songkick, which is our user-facing, our fan-facing website. So they have their own Selenium tests, and they will run. They can't affect each other, so that's fine. The other thing which we do, which works quite well, is particularly because the tests can be a little bit flaky, is the test. All of our Selenium tests are scheduled to run on a schedule. So they run themselves, they trigger themselves every hour during business hours. And what that means is if you don't make a change to a particular project for like 2 or 3 days maybe, we're still getting the test. We don't have to commit code to run those tests, which is really good, because it means that if you do something stupid and accidentally make a change, it will only be an hour maximum before all the tests have run. But it also means if something like we don't control changes, then we know about it quite quickly. So we know when Facebook makes a change because suddenly all of those sign-up tests are failing, and or if Facebook goes down or something like that. So it's actually really useful to if you have got tests like that, to run them on a schedule as well as having them on a commit.
If Facebook goes down?
Facebook goes down.
Facebook Connect or Facebook?
Both. Yeah.
Okay.
Maybe not for long, but if you run your test at that moment, it will fail.
Okay, we should talk about that.
Yeah.
Have you looked at the, there's a slightly different way of doing the acceptance tests where rather than point your acceptance tests at the UI, you would point them at an API level, API layer directly below that, and then unit test or manually test the UI. Is that something you guys have looked at?
So the reason we haven't really delved too far into that is our sort of previous integration suite of tests was more or less like that, and it basically just cut out the UI and tested from there down, right down to the database. The problem is it's pretty slow. You're getting the sort of speed of a full stack acceptance test, but you still don't have the confidence that the user is going to see a usable site. And we had one occasion which was really, really good, where all the tests passed, and we knew we had good tests. We tested all this stuff, and when you came to it unfortunately didn't work because the button to trigger the entire flow didn't work. And that was the one bit that we hadn't tested because it was just the UI. It was much easier. So yeah, we appreciate that there are other ways to do it. I guess it probably depends on your architecture a little bit, like how much API or what your stack looks like. But for us, we found it much simpler to just have to know that these Selenium tests really do look like the site that the user is experiencing.
So
Take one more question, and then people can. Amy still be around for chat.
I have one, but I've had about 5. So does anyone else want to do that?
Jason,
Yeah, what about
Since you've moved to a continuous delivery platform, does that mean that all of the developers have taken up a DevOps role, so they also support it out of hours?
Oh, we already had that in place, but yes.
Can I is that what DevOps means?
Well, indirectly does.
We already had that in place. So our development team, and this comes down to developers having responsibility for things in production. We already have a rota where everybody on our dev team cycles through each week, and they're called what we call firefighting. So if something goes wrong, test environment goes down, production environment goes down, support needs somebody who can investigate a particular problem, that's the one person who you can go to, and they are dedicated to doing that. So, but I don't think moving to continuous integration or continuous deployment would necessarily influence whether you adopted that or not. We had that already, and I think it helped us because developers are very much already geared up for understanding their responsibility for keeping things working, but I don't think you necessarily have to have both parts of that for them to work.
I would say that basically increases the ownership of the live environment. When you get, it's deployed immediately.
Yeah.
Operations usually got more ownership of the live environment. So.
Yeah.
Can we just have a round of applause, please, for Amy for a really...